Hey everybody, Miss T here. Today we're gonna go over some polynomials. Just get ready, find your pen, let's meet at the board. Now, maybe you can see this. There's a couple different ways of writing polynomials. It says, write a polynomial in standard form of degree 3 with real coefficients and zeros at these points. Okay, I'm gonna write this down in our amazing little notability, so it records us for it. And we're gonna talk about what is that, okay? Okay, I took out, before we do this, I took out a couple of the, oh, I'm at the end of a different problem. I guess I didn't even realize. I took out a couple of the things in the question. If you remember, here we have a view in. So the instruction is write a polynomial function in standard form of a degree 3 with real coefficients and zeros at blah. Okay, so this is all coded language. So polynomial function, standard form is, and I'm gonna write a cubic standard form because that's actually degree 3, is you have, okay, you might, what is this? Standard form is you have the degrees in descending order, 3, 2, 1, and 0, okay? Because x to the 0, anything to the 0 power is 1, okay? So that's how you end up with that. So standard form of any polynomial is highest degree first, descending order to 0, 3, 2, 1, 0 of the x's, right? The A, B, C, and D are capital letters. Those are going to be whole numbers, okay? Which are called our coefficients. I'm getting a little wiggle, I apologize for that. Which are called our coefficients, with A being the lead coefficient. Lead. So this word leads us to this part, real coefficients. Well, real means real numbers. Real as opposed to what? As opposed to imaginary, which is this. I is imaginary. Okay? So degree 3, well, I just wrote out 3. Degree 3 means that we have three solutions. That's the coded language inside of the question itself. Okay? So we have 3 solutions, but we have this key part here, negative 4i. We're given zeros at negative 3 and negative 4i. We're only given 2 solutions because a 0, again, coded language, means a solution. Okay? You are interpreting the coded language of the question. And I know, it's weird and it sucks and it's stupid, but it's also a language, and that's the part of mathematics that people don't get, all right? So what you're being asked to find is a potential function, and trust me, there are more than one, is a potential function with these things going on, okay? So here's now the next step of encoding. Remember how I said there are 3? Degree 3 means there are 3 solutions, and we're given 2, all right? Now the zeros, if you remember, the zeros come out of a big string of multiplication. So let's start out with our function. It's going to equal something, okay, where x plus 3 is one of the factored forms because that comes from here. If a solution is negative 3, that means it came out of x plus 3 because, again, if you solve this, right, you subtract 3 from both sides, you get x equals negative 3. X equals negative 3, okay? So that is what is going on. I'm going to erase this because I'm going to hope that people know it because it's in my wheelhouse to go down now. Okay. What we can gather from this is a square, okay? So what would, so here, let's go backwards, okay? Let's do exactly what we did with x plus 3, but now let's go backwards. X equals negative 4i. We're going to move this over and say x plus 4i equals 0. That's the 0. But something happened in here because this is not real. This is an imaginary number. So let's square this. Let's square both sides, okay? And we're going to get x plus 8ix minus 16 equals 0. Okay? Now, we could have gone from here. I know I'm interpreting this, and I don't think the teacher recognizes that this is actually the only way to solve this. But what you would actually do, you could skip this step because we don't actually want this. This is still a complex number. But you could square right from the get-go, x equals negative 4i. Okay? Immediately square both sides, and you get x squared equals negative 16. Because negative 4 squared is 16. I squared is a negative 1. Negative 16. And then we add this back over. Okay? This is how we get the two solutions within the framework of that. But now this is what we have to put in. All right. So this is a baseline, squared, of a potential equation. But we have to make it in standard form. And then we're going to graph it and see if we're correct. So this is f of x equals x plus 3, x squared plus 16. When we multiply this out, right? So I'll make these red so you can see that whole set is red. You're going to have x squared times x plus 16 times x plus x squared times 3. Oop. Oy. I'm running out of space here. 16 times 3. Okay. X, 3, 3, and we've repeated this. When we multiply this all together, of course, we get x cubed. I'm going to put this first. Plus 3x squared plus 16x plus 48. All right, let's take this. So this is in standard form. It's descending order. It's a cubic. Okay. Now let's make sure that our zeros that we did are correctly and got our zeros in the place. Now, this is going to show up weird, but let's see what happens, okay? So let's go over to Desmos. What was that again? X cubed plus 3x squared plus 16x plus 48. Zoinks. Here we have Desmos. Don't ever forget the power of Desmos. Okay. X cubed plus, shoot, what was it? I need to write this down. Oy vey. I need to write this on a regular sheet of paper, don't I? Technology. You guys talk amongst yourselves while I write this down. Okay, there, I got it. See, I got it. Plus 3x squared plus 16x plus 48. All right, so it crosses here. That's what we wanted, -3, we definitely got that. And the problem is, and this isn't a problem, is our 4i is in the complex plane. So we can't possibly know where that is. Well, we can, but not on this graphing. And of course, it's going to cross at 48 because that's the multiplication. Now, this is the slightest little curve.